Okay, so today, well, in these videos, we're going to work toward the goal of having dx go to 0 so that the secant line becomes more and more like the tangent line. That's the goal here. Okay, I want to have an animation so that delta x goes to 0, and okay, I think you guys know what it means for a secant line to become a tangent line. Let me just say, by the way, if you want so this is the x point 1. If you wanted the other point to be over here or something, you could just say dx is equal to a negative number. Okay, so this is what we have. So let's think about what we actually want to change in the animation. The axes should, of course, stay the same, and the graph of the function should stay the same. So the only thing that should change should be this slope group. So I'm going to show you I'm going to show you in this video a way to make this work, but a way that's not going to work really well, and I'll explain why as I go, or maybe not the best way to do this. So all I want to do, again, this is going to stay what it is. That's the graph. It's just going to be this stuff that changes. So I'm just going to do a loop like I did before. So remember in last week's video, every different frame, or we had an animation sort of, and we were just displaying different polygons. So I'm going to do something similar. So I'm going to say, so I want to make dx go down to 0. So I'm going to say dx is equal, actually let me say something like this, del x is equal to 1, and now I need like a delta of the delta x. So delta x means this, and then I'm doing a for loop where I make this go from like 1 to 1.9 to 1.8 to 1.7 and so on and so forth. So I'm going to call this del x, and I'm just going to have a decrement by 0.1 each time. And now I'm going to say while del x is greater than 0, we're going to do some stuff here. So now I'm just going to tab all of this over. So I want all of this to be in the body of the for loop. Okay, so now I want, actually you'll see why I'm going to start this at 1.1. I'm going to say del x is equal to del x minus del x. Okay, but remember, when we want to write something like this, we really want to use the minus equal. So del x minus equal del x. X is equal to 1. Dx is going to be equal to del x. We could have even, well, okay, never mind. So we're going to have that right there. And actually, so I need to move these up here. Okay, so these are going to, whoops. So this is going to create the graph. Whoops. This is going to create the graph. Then I'm going to have this for loop. I'm going to have this play create slopes like this. So it's going to create the slopes. Let's see what's going to happen here. Del x is now going to be equal to 0.1 less than it was in the previous loop. Is going to create this secant line where del x is the updated, del x is going to be the new delta x that we're looking at. So it's going to 0. Okay, then it's going to do self.play create the slopes. So here's the thing. I don't want it to kind of nicely draw the slopes. I just want it to sort of be there in one frame, and then in the next frame go to the next thing, and the next frame go to the next thing, that sort of thing. So I'm just going to use self.add. I don't want it to redraw. I want it to be a smooth animation, not like erase everything, redraw it in kind of a nice way, erase everything, redraw it in a nice way. I want it to be a nice animation, kind of to have that point at 1 kind of slowly move, to have this point right here slowly move along the curve like that. Okay, but now let's think what's going to happen here. If I run this code, it's going to add the slopes. In the next loop, it's going to decrement the del x. It's going to create new slopes and add the slopes. But now we're going to have 2 sets of slopes, as that's not what I want. So actually, what I'm going to do here is I'm going to do self.wait for, let's say, 0.1 seconds. And then I can't remember now if it's self.remove or self.delete. So it's going to delete the slopes and then redraw it again for the one that we want. So let's see what fun errors. Maybe you guys see some errors that I have here. I don't think there are any. Let's see. All right. Slef. There we go. If that was the only error, I'll be happy. Okay, so okay, that does exactly what we want. Does that slope. Now let's see what happens. Hey, it looks pretty good. I mean, there's definitely something weird happening here. Okay, maybe this is around 0.1. It's kind of maybe not as choppy, or is not as smooth as maybe we want it to be. Okay, so here's what happens. So here we have a great off by 1 error type of error. So when del x here is equal to 0.1, in the x iteration it goes down to 0, and I guess that's what happens. This is what happens when del x is equal to 0. So now I really want this to go down to del x. Okay, that'll be the last one. So as soon as del x hits 0.1, it's not going to do the next loop. So okay, so we'll see what happens when I run the code. Okay, and then we get something weird that happens there. I do not understand why that's happening. So this little thing that's happening here, I have not seen this before. I mean, I am also purposely doing this in the way that I would not want to do it, but I have no idea why that's happening. I don't know why I'm running it again, as if that will change something. Yeah, that's weird. That is very, very unpredictable to me, or that I would not have predicted that. Okay, so let's see what happens. I add the slope, I wait 1/10 of a second, I remove the slope, so like on the very last iteration, let's say del x is equal to 0.2, or let's say del x is equal to 0.1, then it comes up here, while del x, so it's going to be equal to 0.1, so it shouldn't do that loop again. This is never equal to 0 though, because this del x has to be at least 0.2. Okay, so I honestly don't know why that's happening. Yeah, I can't explain why that's happening. I don't know why that is doing that. Let me try this. Is it just because like 0.1 is getting too close? I don't think so, but I want to see what's happening here. Well, that seemed to work well. So okay, so let's do an experiment here. So what about if I do, instead of 0.1, I do 0.05. This will sort of tell me whether or not I have some off by 1 error in the loop that I haven't paid attention to, or if there's just something wrong about if delta x gets too small, or the delta x gets too small. Of course, we're going to have way more, there's way more iterations for this loop now, because we've got 0.05 here, so the animation will take longer. Okay, so there's just some off by 1 error here that I have to think about when I'm not trying to teach, because obviously I don't know if it's the same with you guys, but I cannot think through what's going on while I'm trying to explain something. I get all nervous and embarrassed that something unexpected happened. Okay, but anyways, this is one way where we could affect an animation. Okay, but now let's think through what package we're using. And of course, if we wanted to make it less choppy, we could do things like make this even smaller. Okay, but let's think through what package we're using. We are using a package called mathematical, or called Manim, which is short for mathematical animation. And here we're kind of like hand coding an animation. This is like just a more sophisticated version of making a flip book, which of course is what all animations are. But we're using a package that is supposed to help us do mathematical animations. So it seems like probably there should be some built-in way to do this that handles a lot of this stuff a little bit better than the way that we're handling it. And that's what we're going to be looking at for the next few videos. We're going to be looking at things called value trackers, updaters, and things related to that for the next couple of videos. But I think you'll agree, this is a pretty cool animation, right? You can make it even better than I did. Probably not that difficult. In certain ways, you can even have something up here that computes the slope of this and shows that it goes to what the derivative should be. And another thing that I want to point out here is if I want to do something other than a square, like let's say I want to do sine, all I have to do is change it to sine there. And okay, sure, I might want to have a different domain than going from -1 or -2 to 2 or whatever I had. But if I want to do that, I can just change my x-min and x-max and my y-min and y-max up there. So actually, I just realized I have y-min doesn't go negative, so I might have a weird looking graph here. Okay, and again, I think this looks pretty cool. There's definitely ways that we can make it better. The labeling there looks a little weird, stuff like that. There's definitely things that we can make better. But the point is, I think that this is sort of a bad way of doing it. And even that's not so difficult, and I think it looks pretty cool. And I think this would be very cool if you could make an animation, something up here, computing the slope, having labels for the coordinates, all of that. So that's what we're going to be looking at things similar to that for the next few videos.